Welcome back to the Table Talk series where we cover NFPA 72, Chapter 14, specifically the test table and the inspection table. We're going into now component 3 of the series, so stay tuned to the end where we have some test questions so you can test your knowledge to see what you've learned. So there are 30 components on the test and inspect tables, the inspect table being 14.3.1, the test table being 14.4.3.2. These are important points for the inspection process of the fire alarm system. So let's go over component number 3. So this is the NFPA 72 2025 National Fire Alarm and Signaling Code. This is going over Chapter 14, Inspection, Testing, and Maintenance Tables, the Educational Field Guide. This is component number 3. And component number 3 covers the alarm control unit, specifically our trouble signals. All right. So the alarm control unit trouble signal is the FACU's own built-in mechanism for notifying building staff and the supervising station that a fault condition exists within the fire alarm system itself. Trouble signals are distinct from alarm and supervisory signals. They indicate a system impairment that requires investigation and correction, not a fire event. And that one's important if you've ever done on-call or any other service. Per NFPA 72 10.10.6, trouble signals shall be distinctive and different from alarm signals in both audible tone and visual indication. The purpose is to ensure no one can mistake a system fault for a fire alarm and that no fault goes unnoticed or unreported. Annual testing under Table 14.4.3.2 verifies that the FACU correctly produces, enunciates, transmits, re-notifies, and restores trouble signals for all applicable fault conditions. Table 14.3.1, the visual inspection table, component number 3 or item number 3 is reserved. There is no visual inspection requirement for component number 3. All testing for alarm control unit signals is performed under Table 14.4.3.2 only, the testing table, on an annual basis. So here we have a little diagram, hopefully helps people understand a little better. So we got our trouble signal life cycle. We got step 1 fault detection and signal generated. So we have a fault detection, a fault condition, like an open circuit or a ground fault, which goes to the FACU, detects faults, generates trouble signal. You get the audible plus visual, interrupted tone plus trouble LED, and then the supervising station, if monitored, the trouble signal transmitted. Step 2, after acknowledgement, audible silence, the trouble tone stops on acknowledgement, visual LED stays on until fault fixed. So you still have a trouble visually indicated on your panel. And then re-notification. If fault persists, audible resounds at programmed interval. Some panels are programmed with an interval. As an example, every 24 hours, if you acknowledge a trouble and don't do anything for 24 hours, the panel will resound or re-notify of that signal. And step 3, fault corrected / restoral. FACU generates restoral signal. Trouble LED extinguishes. Panel display returns to system normal. Restoral signal transmitted to supervising station. Event log records trouble onset and restoral with timestamps. There's always timestamps. Oops, hold on. There we go. There's always timestamps. So this is just a little diagram. So we have our NFPA 72, Table 14.4.3.2, testing, this is for the test table, alarm control unit trouble signals, done by a qualified personnel on an annual basis. All sub-items under Component 3 are tested annually. Regardless of system monitoring status, testing shall be performed by qualified personnel. All affected parties, occupants, supervising station, and building owner shall be notified per 14.2.4.1 prior to testing. Per 14.1.6, 2025 edition, testing personnel are not required to evaluate the design adequacy of a previously approved existing system. Right? So you test the system as designed. So audible and visual, which is done on an annual basis under the testing table 14.4.3.2. So verify the FACU produces an audible and a visual indication when a trouble condition exists, and that the trouble signal is distinct from alarm and supervisory signals per NFPA 72, 10.10.6. Additionally, verify ringback with the reset switch. If the reset switch is operated while a trouble condition is still active, the audible trouble tone must resound, or in parentheses ringback, to alert the operator that the fault has not been corrected. Verify trouble signals, audible and visual. So these are your step processes. So introduce a trouble condition on the system, which it can be an open circuit, device fault, or other fault source. Verify the FACU produces an audible trouble tone distinct from alarm signals in tone, cadence, or pattern. And some older panels will have the same distinct patterns. Newer panels will kind of distinct between an alarm, supervisor, or trouble. So it also depends on when your panel was installed and the code at the time. So verify the trouble LED, typically yellow/amber, illuminates at the panel. Acknowledge the trouble signal. Verify the audible tone silences and the visual LED remains illuminated. So it stops beeping, but the trouble still displays on your panel. Verify the panel display correctly identifies the location and type of the trouble condition. Verify the visual trouble indication extinguishes only when the fault condition is actually corrected, not on acknowledgement alone. So if you acknowledge the panel or silence the panel, and somehow magically the trouble disappears, it better be because the trouble's clear. If it disappears because you acknowledge the panel and for some reason it clears it, there's something wrong with the program or the panel. Right? Just because you acknowledge a trouble signal does not mean it goes away. You actually have to correct the trouble before it goes away. You actually have to fix it. So next, verify ringback with reset switch. So first step, with a trouble condition still active on the system, operate the reset switch at the panel. Verify the audible trouble tone resounds, or in parentheses ringback, immediately or shortly after reset is operated, confirming the trouble has not cleared. This ringback confirms the FACU is actively supervising the fault condition and will not allow a reset to mask an unresolved trouble. Correct the fault condition, then operate the reset switch again. Verify the panel returns to normal without ringback, confirming the fault is resolved. Some panels will clear automatically. Some panels you have to reset to clear them, but you have to correct the trouble first for the trouble signal to clear. Ringback failure, deficiency. If the panel resets to normal condition while a trouble is still active and the audible does not ring back, the panel is failing to supervise the fault. This must be documented as a deficiency, and the system must not be returned to service until corrected. So if you do a reset and the trouble clears, but its trouble has not actually cleared from the system, it's only cleared from the panel, and there's still a fault in your system. So you need to fix the fault in your system. So next is disconnect switches. Again, tested on an annual basis. So you verify the function of each disconnect switch on the FACU and verify that the FACU correctly generates and displays a signal upon activation of each switch. Disconnect switches are used to isolate or disable individual circuits, zones, or system functions for maintenance or service. The FACU must indicate that a portion of the system has been disconnected so that the condition is not overlooked. Verify function. First, identify all disconnect switches on the FACU, in parentheses, zone disconnects, circuit isolation switches, or similar. Operate each disconnect switch and verify the associated circuit or zone is properly isolated. Devices on the disconnected circuit should no longer be supervised. Verify the disconnect switch physically operates correctly with no mechanical binding or failure. And in modern panels, it could be a push button or it could be a physical switch where you toggle like a light switch up and down. So depending on the panel, this is going to be different. Restore each disconnect switch and verify the circuit zone or zone returns to normal supervision. Stuttering, sorry. Verify receipt of signal. When a disconnect switch is activated, verify the FACU generates the appropriate signal. Typically, a supervisor or trouble signal indicating the disconnected switch. And depending on the panel, it could be a different name between supervisor and trouble or another. So you need some sort of visual and audible indication when you disconnect something or when you disable something. Next, verify the signal is clearly enunciated at the panel display with identification of which circuit or zone has been disconnected. For monitored systems, verify the disconnect signal is transmitted to the supervising station so the monitoring company is aware a portion of the system is out of service. Very important if your system is monitored. Whatever you do at your panel, if the system is monitored, make sure the monitoring station receives an appropriate signal. Very important. Next, verify the signal clears when the disconnect switch is restored to normal position. Impairment notice required. Any disconnect switch left in the isolated position during or after testing constitutes a system impairment. The building owner must be notified in writing of any portion of the system that is disconnected and not immediately restored to service. So basically, don't leave a fucking panel disabled when you're not testing. If you're done for the day and you did not restore your panel to normal, meaning you did not enable your panel after you disabled something, you fucked up, right? You need to make sure you enable the panel, put it back to its original status. Maybe there's an existing trouble, that's fine. Maybe there's an existing problem, that's fine. But if you disabled something for your inspection, you need to make sure you re-enable it before you leave. It's very important. Same thing with monitoring. Verify disconnects over monitoring. Verify everything over monitoring. You need to make sure you're following through with your job. Every step. Right? So next is ground fault monitoring. Again, is on an annual basis. So verify that the FACU correctly detects and enunciates the occurrence of a ground fault on system wiring. A ground fault occurs when a conductor comes into contact with a grounded surface, potentially causing erratic system behavior, false alarms, or loss of supervision on a circuit. NFPA 72 requires the FACU to supervise wiring for ground faults and generate a trouble signal when one is detected. So your step process. Introduce a ground fault condition by connecting one conductor of a circuit to a known ground point. Verify the FACU detects the ground fault and generates a trouble signal identifying the affected circuit or zone. Verify the ground fault trouble is enunciated both audibly and visually at the panel. For monitor systems, verify the ground fault trouble signal is transmitted to supervising station. Very important. Remove the ground fault condition and verify the trouble signal clears and the panel returns to normal. Document the ground fault test results, circuit tested, FACU response, and restoral in the inspection and testing record. So I have videos on how to ground fault test panels because I know it's something not commonly done in the industry. So this is kind of a sticking point for me and the whole point of this fucking channel, right? So ground fault monitoring, just verifies that if a ground fault is on your panel, meaning a random copper wire through one of your lines connecting a horn strobe, a smoke detector, whatever initiating device, whatever output device, like if metal's touching metal, like the copper wire gets cut or whatever, and it's touching a piece of metal, it's going to leak out electricity, right? Which means whatever device it's connected to won't have the full power of the panel, giving it what it needs. So if it's a horn strobe, it needs, a certain amount of volts. If it needs a smoke, certain amount of volts, or whatever. Certain devices need a certain amount of power, right, to function properly. It sends a signal back and forth. So if the line's cut and it's touching something that's metal, the electricity flowing through the wire isn't going to be able to travel properly. It's going to get grounded to whatever metal is touching. It's going to leak out and effectively hinder your system. Ground fault testing is not something that I've seen commonly tested in this industry, so it's very important that you do it. Next, transmission of signals to off-premises. Again, this is an annual test. So verify that alarm, supervisory, and trouble signals are all correctly transmitted to the off-premises supervising station. Each signal type must be transmitted distinctly so the supervising station operator can correctly identify and respond to each. Additionally, and critically, verify that alarm signals can still be transmitted even when the panel is in an active trouble condition. A panel that cannot send an alarm while in trouble could fail at the most dangerous moment. All right, so you want to make sure even when your panel has whatever trouble condition it is, a device or whatever, it can still send out alarm signals. It's very important. Verify transmission of all three signal types. So first, place the supervising station on test mode before initiating all signals. Alarm signal. Initiate a test alarm. Activate an initiating device, in parentheses. Verify the alarm signal is received at the supervising station and correctly identified as an alarm. Supervisory signal. Activate a supervisory device. Parentheses, sprinkler tamper or disconnect switch. Verify a supervisory signal is received at the supervising station and correctly identified as a supervisory. Trouble signal. Introduce a fault condition. Verify a trouble signal is received at the supervising station and correctly identified as a trouble. Verify each signal type is transmitted with sufficient identification, system, building, zone/address for the supervising station operator to act appropriately. Verify alarms can be sent while panel is in trouble. Introduce an active trouble condition on the panel, e.g. open circuit or on a zone. With the trouble condition active, initiate a test alarm on a separate circuit or device. So purposely create a trouble, if there's not already one, and then test one of your initiating devices or alarm signals. And make sure that the panel activates an alarm and it goes to supervising station, right? So when your panel is in fault or in trouble, it can still function properly. Next, verify the FACU transmit the alarm signal to supervising station even with the trouble condition is simultaneously active. So that's what I just fucking said, right? So if your panel goes into trouble, that doesn't matter for an alarm condition. If an alarm condition activates, even with your panel in trouble, your system still responds to a fire. It activates the panel. It calls out to the supervising station. It activates all your output devices, your horns and strobes. It drops doors, shuts down HVAC units, fan dampers, elevator recall, whatever. Right? Like your system still functions. Just because it's in trouble doesn't mean that your system still doesn't function. So you're making sure that this all works. Verify the supervising station receives both the alarm and the trouble as separate, correctly identified signals. Very important. A trouble is a trouble, and alarm is an alarm. They are not the same signal. This test confirms the trouble condition does not block, override, or delay the transmission of life safety alarm signals. Very important. Pass criteria. All three signal types, alarm, supervisory, trouble, are transmitted to and correctly identified by the supervising station. An alarm signal is successfully transmitted to the supervising station while an active trouble condition exists on the panel simultaneously. Failure of either condition is a deficiency requiring immediate correction. All right, here we go. Knowledge check time. Let's see what you've all learned, if anything at all. All right, let's try to improve, right, in our field. Right, let's try to improve and learn. Right. So we have knowledge check for component 3, alarm control unit trouble signals. This is for the NFPA 72, 2025, and for this specific component 14.4.3.2, which is the test table, I'm going to select the best answer for each question. Question 1 of 3. During testing of the audible and visual subcomponent, a technician acknowledges and silences the trouble tone, then operates the reset switch while the trouble condition is still active on the system. What should happen to pass the ringback test? Is it A, the audible trouble tone must resound, or in parentheses ringback, confirming the FACU recognizes the trouble is still active and will not allow a reset to mask an unresolved fault? Is it B, the panel should reset to normal condition? The reset switch overrides any active trouble and returns the system to standby. Is it C, the panel should lock out and require a service technician's code before any further operation is allowed? Or is it D, the visual trouble LED should extinguish briefly during the reset operation, then re-illuminate after 30 seconds? So put your answers in the comments. Let me know what you think for question number 1. Question number 2. When testing disconnect switches under subcomponent 3B, what signal must the FACU generate when a disconnect switch is activated? And what additional notification is required if a switch is left in the isolated position after testing? Is it A, an alarm signal must be generated? No additional notification is required as long as the technician documents it in the test record. Is it B, no signal is generated? Disconnect switches are maintenance tools only and are not supervised by the FACU. Is it C, a ground fault signal must be generated? The supervising station automatically places the building on impairment watch list. Or is it D, a supervisory or trouble signal must be generated indicating the disconnected condition? If any switch is left isolated after testing, the building owner must be notified in writing as the system is impaired. So for question 2, what is your answer? What do you choose? All right. Finally, question 3. During the transmission testing under subcomponent 3D, a technician introduces an active trouble condition on the panel, then activates a test alarm on a separate circuit. What must occur for this test to pass? Is it A, the panel must prioritize the trouble signal? The alarm transmission is held in qui and sent only after the trouble condition is resolved. Is it B, the alarm signal must be transmitted to the supervising station immediately while the trouble condition remains simultaneously active? Both signals are received by the supervising station as separate, correctly identified signals. Is it C, the panel must cancel the active trouble signal when an alarm is initiated, transmitting only the alarm to avoid confusing the supervising station? Or is it D, the test is not valid? Alarms and trouble conditions cannot be active simultaneously, and the panel must be restored before alarm transmission can be tested. Take a guess. What is your answer for question number 3? Right? And that is the end of component number 3. So again, the point of this series is to go over the codes in the book. A lot of my videos up to this point have been a practical application in the field of how to use these codes on whatever system you're testing. This series, this Table Talk series, is focused on the codes themselves and the theories that go along with them. So we're just going over the book, trying to understand the code, and trying to apply it to what we understand. So go ahead and give each of these questions a shot. Answer your questions in the comments. Let me know, and I'll give you my response. Thank you for watching, and have a good day, and see you on the next component.